Hi Doctor, today we're going to present on Principle of Data Science Assignment 2. We are from Group 5. Our topic and dataset we have chosen is Medical Cost Personal Dataset. This dataset can be downloaded from Kaggle. We consist of two members, one is me, Ong Khai Siang, and another one is Chong Twau.
Greetings to Dr. Muhammad Farhan Muhammad Mohsin. My name is Chong, matrix number 208751 from Group 5. And now I'm going to answer the question in Assignment 2. So question 1, determine a type of learning. In Assignment 2, we're going to use supervised learning. Why? Because we plan to make prediction based on the past data sets and find the association between an independent variable with predictor and a dependent variable target, and predict a continuous response, which can be on a range of infinite values. Question 2, describe the model that you plan to develop. In Assignment 2, we plan to develop a regression model. Regression can be defined as a way or modeling technique of predicting future happenings and outcomes by investigating the relationship between an independent variable, predictor, and a dependent variable target. Why we use regression model? Because it implements a regression analysis which to indicate the significant relationship between an independent variable and a dependent variable, thus show the impact of predictor on a target. And second, it can be used to predict a numeric value. And third, regression model is used in forecasting time series modeling and finding causal effect relationship between two variables. And question 3, name of algorithm. In Assignment 2, we will use linear regression algorithm, or more specifically, a simple linear regression. Give the brief explanation about the algorithm. Linear regression establishes a relationship between dependent variable and one or more independent variable using a best fit straight line, also known as regression line, which can be represented by y equal to mx plus c, where y equal to dependent variable which is target, m equal to slope, x equal to independent variable which is a predictor, and c equal to the y-intercept. And there's two types of linear regressions. First, simple linear regressions, which involve only one independent variables, predictor, and one dependent variable, which is target. And multiple linear regressions, which involve multiple independent variables, which is the predictor, and only one dependent variable, which is the target. Justify why the algorithm is selected to build the model. Linear regression algorithm is selected because it is applicable for continuous or numeric value, which meets our purpose to predict the medical cost billed by health insurance, which is the charge by using the age of primary beneficiaries. And second, it helps to solve prediction problems, and it shows linear relationship between independent variables, predictor, and dependent variable target by using a straight line, regression line, which is y equal to mx plus c, which mentioned before. And we have decided to apply simple linear regression for this learning, and since we're using the simple linear regression, there's only one input variable, predictor, and one output variable, which is the response variable. And simple linear regression predict continuous numeric value by using a single feature, only one input variable, which is the predictor. Determine the output of knowledge that can be extracted from the algorithm. From the linear regression algorithm, we can get a linear equation y equal to mx plus c, which shows how the value of dependent variable, which is the target, is changing according to the value of independent variable, which is the predictor. And second, we can get a correlation coefficient, which is used to measure the strength of the relationship between two variables. The values of correlation coefficient always have a range of between -1 and +1, where -1 indicates strong negative relationship between the two variables, while +1 indicates strong positive relationship between the two variables. Well, there's also a possible of 0, which indicates that there's no linear relationship between the two variables.
Before we begin our Assignment 2 coding, we need to clean the data before presented into machine learning algorithm. So we will check we have any outlier for our two data, which is ages and charges. So as you can see, we use box plot for ages and see that there is no outlier for ages, while charges outlier is shown at the box plot after the whisker, which is the dotted place. So we can see that charges have outlier. Therefore, we started to clean the outlier by removing it. So now we will insert ages and charges attribute in our new data frame only. So we use box plot. So as you can see, a raw data set which haven't been cleaned, the highest maximum of the charges is more than 60,000, as you can see the few dotted there. So we have decided to use box plot tools, which is using the interquartile range IQR method. As you can see, the interquartile range method, which minimum than the IQR, which is the formula Q1 minus 1.5 times IQR, the minimum less than the minimum will be our outlier, and also maximum, which is Q3 plus 1.5 times IQR, more than the maximum is also our outlier. So for the code, remove outlier IQR. Therefore, our box plot we print out again. So therefore, you can see that our highest charges now is 35,000, compared to just now is 60,000 and above. So that now we have know that our outlier have been removed and our data for charges is more clean. So to check our outlier, how many outlier have we removed? Okay, we will use length. Length, the function is return the number of items in an object. So length, we just know that index difference. We will know that we will have 139 outlier being removed. So we will print out a df describe. Previously, we have 1,338 data in our age and charges. But now, after we remove the outlier, we will have 1,199. And you can see our maximum is 34,472 compared to just now is 60,000. So our outlier has been solved. Now we need to know that we have any missing value. So we have know that our missing value is 0 because we use data frame is now dot sum. We have no missing value. Data set are complete. We are using supervised learning. Therefore, we will have to split the data into train and test to up to 5 set of fold. Then we will create x train, x test, y train, y test equals to train test split, x, y, test size 0.6, which is 60% test, and also random state equals to 0. Random state equals to 0 is because that every time we are run, we have the same output. So once we train the algorithm, we will print linear regression intercept and also print linear regression coefficient. So we will look below. As you can see, our linear regression intercept is as below 2075.75, while our linear regression coefficient is 206.31. What is mean that at every one increase in ages is associated with a charges increase of RM 206.31 charges. So for our intercept and coefficient we have done. So now we will look into our making prediction. Then after all those is done, we will start on evaluate the algorithm performance. We will have 3 model performance we are using, which is MAE, mean absolute error, MSE, mean square error, RMSE, root mean square error. So we are mainly focused on RMSE on our best model performance. So after that, all the 5 set of 4, we will look which is the minimum root mean square error, then that will determine our best model for this linear regression. So as you can see, for this 60% test, MAEs will be 4865.32. For our mean square error, we got 42135,000.76. While our RMSE, root mean square error, we will have 6491.15 for our RMSE. Then we go to our 50% train test data. So our intercept line, we will get 2066.86, while our coefficient will be 206.346. For our MAE, we will get 4840.70. For our MSE, we will get 41672237.52. While our root mean square error, which is 6455.40, which is much lower than previously. Then we go to our train test data, which is test is 40%. For our test is 40%, we will have our intercept point, which is 1499.34, while our coefficient is 221.09. For the MAE is 4664.84, while the MSE is 38913,815.58. While our RMSE, root mean square error, we will get 6238.09, which is much lower than previously. So for our train test data, which is our test is 30%, we will get the intercept is 1264.89, while coefficient is 226.36. For the MAE is 4555.76, while the MSE is 3798.00, while for the root mean square error, RMSE got 6113.41, is the most lowest compared to the others. For our train test equals to 20%, the test is equal to 20%, we will get the intercept is 1159.21, while the coefficient is 227.44, while the MAE is 4521.09, the MSE is 39805.025.55, while the RMSE, root mean square error, is 6309.12. As you can see, it's much higher than compared to previous train set data. As our lastly is 10% of our test data, we will get intercept is 964.54, the coefficient is 229.60, for the MAE is 4798.61, while the MSE is 4873816.39, while the RMSE, root mean square error, is 6981.27. So it's also higher than the 30%. So to conclude that, our lowest and our best model for root mean square error, RMSE, is train test data 7030, which is 30% test, and it have root mean square error of 6113.41.
Determine the best module. Describe your findings in terms of mean absolute error, mean square error, root mean square error based on training and testing data. As mentioned by my teammates Ong Khai Siang, The best module based on the training and testing data is Twau, which is trend test in a ratio of 70 to 30. The reason is it has the lowest value of root mean square error, which is 6113.41. Root mean square error IMSE is selected as our main performance metric because it is used to measure and compute the average error of the prediction which is performed by the linear regression model. The lower the value of IMSE indicates the better the performance of the linear regression model in predictions. Thus, the accuracy of the linear regression model is higher. Twau helps produce the best prediction performance by the linear regression model among other forms of training and testing data. We choose root mean square error RMSE over mean absolute error MAE and mean square error MSE to be our main metrics performance is because that MAE is less sensitive to outliers if it is compared to RMSE, while MSE is computed in a square unit as the units of the response variable, which is RM for the charges. So RMSE is the most suitable as it is computed as the same unit as the response variable, which is RM. It is clearer for us to interpret and see the result. Question 5. Data science produces knowledge. What is the knowledge that you have gained from this learning and how it can be applied in the real world? From our learning, we get to know that the increment of 1 in age will bring about the increment of 226.36 in the charges, which is the medical cost bill by health insurance. We get a linear equation about the relationship between age of the primary beneficiary and charges. And based on this equation, we can predict the medical cost bill by health insurance, which is the charges. So in order to have comparison, we have two different ages, which is 26 years old and 46 years old. When age, which is the predicted, equal to 26, the charges, which is the target, equal to 7,150.379,064, while when the age equal to 46 years old, the charge will be 11,677.67742. And from the result, we know that the older the age of a person, the higher the charges with the medical cost bill by health insurance. And the correlation coefficient between the two variables investigated in this learning is 0.3, which is a positive relationship between age and charges, which is the medical cost bill by health insurance. In summary, the knowledge we gain in this learning is that age of the primary beneficiary is affecting the charges, which is the medical cost bill by health insurance. And the increase in charges, which is the medical cost bill by health insurance, is associated with the increase in age. And the older the age of a person, the higher the charges. And how it can be applied in real world. Age is one of the important criteria and features to predict a medical cost bill by health insurance. People can make use of this feature to predict the charges before purchasing any medical insurance, as nobody can prevent from aging or getting old. The insurance agent could help the buyers to make predictions on the medical cost bill by health insurance based on their age in advance before moving to a further discussions. While the buyer itself, who intends to buy a health insurance, could make predictions on the medical cost bill by health insurance based on their age to determine the most suitable age to buy a health insurance. Let's have some real-life examples of applying linear regression to make predictions. First, in the medical field. The linear regression can be used in understanding and predicting the relationship between drug dosage and the blood pressure of a patient. While the predictor, which is the independent variable, will be the drug dosage, while the target, which is the dependent variable, will be the blood pressure of a patient. While in another field, which is sport field, in NBA, the National Basketball Association, the data scientists might try to analyze the effect of number of training sessions on a player performance. And the player performance is evaluated by the point score. Linear regression is used in understanding and predicting the relationship between number of training sessions and point score by players. While the number of training sessions will be the predictor, which is the independent variable, while the point score by players, which is the player performance, will be the dependent variable, which is the target. That's all from me. Thank you.